Hey guys, so today I'm going to talk to you a little bit about the key characteristics of a parabolic function or key characteristics of quadratic functions. So first I just want to bring it back to the idea of where we can see parabolas in the real world. Okay, so where you might see parabolas in the real world, we've discussed already some roller coasters, right? Those produce U-shaped figures. You might think in sports like soccer or football, where a person is at ground level, kicks a ball, reaches its maximum height, and then eventually drops back to ground level. Okay. Other ways we've also considered parabolas in the real world. You might think about even in the McDonald's sign, right? So the double arches. This could be one parabola mirrored by another parabola. Okay, or anywhere you might see an arch, might be walking through a gazebo or anything, could be a door. There's lots of opportunities where you might see a quadratic function in real life and may not even realize it. So today I'm just going to walk you through some of the key features of a quadratic function. Okay, so the main thing that's important, so we initially said that quadratics are polynomials with degree 2. Okay, so meaning it has x squared. So anytime you see that the highest exponent is x squared or to the power of 2, then that means that it is a quadratic function. So we talked a little bit about that last week. We know that a parabola is a graph, which is a quadratic function. So we said they're U-shaped graphs. And U-shaped graphs can either open up or they could open down. And we'll learn more about that ability in this lesson. Okay, and then there are going to be a couple of new terms. So you can see I've already highlighted it for you in color coding, I guess matching, so that you can see amongst the parabola where these new terms are. The one that's going to be the most familiar to you is going to be your y-intercept. So even when we're dealing with linear relations, we knew a y-intercept is where the graph crosses the y-axis. So let's start with that one because that one is familiar. So as you can see here, your y-intercept is in fact at 0, 3. Okay, and again, that's where the graph crosses the y-axis. You also might be familiar with x-intercepts. Okay, so x-intercepts have actually a couple of different names. So x-intercepts can be called roots, they can be called zeros, they can be called solutions. So depending on what your textbook or what your assignment may say, any of those words or terms are suitable, and they refer to where the graph crosses the x-axis. Okay, so if you take a look at just where I'm highlighting this x-axis, you'll notice in this case the roots or x-intercepts are shown in two places. So the first place is right here at 1, 0. The second place is to the left of that, which is negative 3, 0. Now for parabolas, they can have up to 2 x-intercepts. Okay, they can have one x-intercept, and in some cases they may not have any x-intercepts. But for now, we'll just consider the different opportunities as to understanding where these x-intercepts could be. But in most cases, let's just say you will most likely find 1 or 2. Okay, we've already talked about your y-intercept. Your vertex is going to be a very important part of your parabola. Okay, so you can see here that it's highlighted in purple. Your vertex is your turning point. So your turning point in this case is at that purple dot. So in this case it's negative 1, positive 4. And you can notice if I was to start tracking this parabolic function, it increases, 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 hits a max, and then it begins to decrease. So meaning it turns directions. It goes from going up to then going down. Now where to identify that vertex is exactly what I just said earlier. Your vertex will then be at -1, +4. Your vertex can have one of two scenarios. It can have a maximum, so that's when the vertex is the highest point. So in this case, you'll notice this parabola opens down, and the vertex has a high point, which is what we call a maximum. When a vertex has a minimum, that's when our parabola opens upwards. Okay, so you can see our minimum is actually a low point. Okay, and last but not least, our axes of symmetry. So your axis of symmetry is a dotted line that goes down the middle of your parabola, and I want you to think of it like a mirror reflection. So the shape that's contained to the left of the left wing of the parabola is actually mirrored on the right side as well. Okay, so meaning it looks like a U shape, and it does have that mirror effect, where if you were to take a mirror and if you were to draw the reflection to the other side of this left arm parabola, you will see that it will be exactly where the right arm will be. Okay, so yes, there are a couple of new terms, right? So roots, x-intercepts is the first term, y-intercept, again, where the graph crosses the y-axis. The third is a vertex, and then acknowledging when it could be a max or a minimum. And then the fourth would be axes of symmetry. So let's take a look at some of these examples. Okay, so at the very top of the second page here, just to highlight a couple things that I've already mentioned. Okay, so your vertex, again, is your turning point, and it's a very obvious thing to look out for. When you open up, you have a minimum. When you open down, or when it opens down, you have a maximum. And then remember that orange line that we discussed, our axis of symmetry. It is the symmetrical line that goes down the parabola. Okay, so we're going to take a look at these two examples here, and we're just going to work on naming some of those key elements that we talked about on the first page. Okay, so if we were to find our vertex of the first example, you'll notice your turning point is at 0, -3. Is it a min or max, and what's the value? Well, because this parabola opens up, it has a minimum, and the lowest value is actually going to be the y part of our vertex. So our min value is at -3. Okay. Your axis of symmetry, remember, is that dotted line that goes down the symmetrical part of your parabola. So in this case, the dotted line would go down x equals 0. And you'll notice that's also actually the x part of your vertex. They should match, always. Okay, your x-intercepts. Now, these x-intercepts are not at the exact value, okay? However, what you can kind of gauge for is where they would be if you were to consider where those values would be on the x-axis. Okay, so you know what? This actually would be at, let's say, approximately 1.80, and the other x-intercept might be at approximately -1.8 and 0. Okay, in future it will be very easy to identify, similar to how these ones are easy to identify. But in cases where you can't really see, it's a good idea just to kind of make mention of where approximately it will be, at least for now. Okay, direction of opening, we've already said that this opens up. And then your y-intercept is where the graph crosses the y-axis. So in this case, 0, -3. Okay. All right, let's try another one. So this parabola to the right has a vertex at -1, +5, so we write that as a coordinate. Max or min value, well, this parabola opens down, and parabolas that open down have a max value, and we need to rewrite where this max value occurs. It's at y equals 5. We can add that y equals. Okay. Axes of symmetry, so again, if I was to draw that dotted line that goes down the middle of your parabola, it would be at -1, which, as you noticed earlier, is also the x part of your vertex. Now make sure whenever you write your axis of symmetry, it's always in the format of x equals and then the value of your axes of symmetry. Okay, for your x-intercepts in this case, I would say this is at approximately 1.2 and 0. And the second one would be approximately -3.2 and 0. Direction of opening, we've already mentioned it opens down. And your y-intercept, so looking at your y-axis, it's looking like it's at 0, +4. Okay, if you feel like you do need extra support, you can take a look at the section 6.3 lesson, which is on page 254 in your textbook. Okay, if you have any further questions, please let me know, but basically